Hi everybody, we are live. Welcome to my Curious Maths page and my second live stream. So if you can hear me and it's all working well, if you could say a quick hello in the comments, that would be great. And it would also be quite nice to hear where you are in the world, because I always find it quite interesting to find out how wide the spread of Numicon is. So yeah, pop a quick hello in. So something about myself, my name is Sarah Tilley. I'm a primary maths consultant and I'm based in North London, Enfield. I have been in education for over 20 years, and my last job I worked with Enfield Local Authority as a primary maths consultant, and I did loads of mathsy things like team teaching with teachers, working with maths leaders to improve maths in schools, coaching, all sorts of things. So it's great, it's a great opportunity and I loved it. And now I do the same thing actually, but I work for myself. So that's a little bit about me, and the focus today is going to be thinking about how you could use Numicon at home with slightly older children. So last week I did a stream about using Numicon with 3 to 7 year olds, 4 to 7 year olds, and this week we're going to think about what it would look like with the children who are slightly older. And I was very keen to do this stream because sometimes it's thought that Numicon only works with children who are young, and that is not the case at all. And so I use it loads and loads in Key Stage 2, and it works time and time again. So I'm really glad to be able to be sharing you some ideas. So how this session is going to work. I'm going to do some demonstrating, some modelling with Numicon. I'm going to do a bit of PowerPointing, but what I really want from it is for you to be interactive. So I am looking for you to get your Numicon out, practice the activities alongside me. If you've got any questions, please type them in the box. And any comments actually about the activity, whether you like it. And I have somebody to help me today. So the lovely Harry is here. Harry is one of my Curious Mathematicians Club teachers. So I've got an after school programme that runs in Enfield and Barnet. And Harry is one of my amazing teachers. So hi, Harry. And she kindly volunteered her services today. So she's going to keep an eye on the chat, and she's very Numicon savvy. So if you've got any questions, she will try and answer them. And then I will also go back later. So I'll spend a bit of time seeing what you've asked and replying back to you. Right, so let's think about what is Numicon. That's a place to start. So when we talk about Numicon, this is what people think about, the Numicon shapes. And these are only a part of the bigger picture. So what Numicon actually is an approach. It's a doing, communicating approach. So the idea is, through the Numicon approach, that children get busy. They get active as mathematicians, they do things, and whilst they're doing and talking, perhaps using the Numicon shapes, they start to communicate their maths ideas, what they're learning, start to use maths vocabulary, and they communicate with their peers about the maths they're doing. And what that does is confirms to their memory the actual maths, but also helps them practice that. So when they talk to the teacher or an adult, a parent, about the maths they've done, they've got something they can hook it onto. So it's really great for that. Also, part of this approach is all about seeing structures and seeing patterns. And I touched on it a bit last week, but Numicon is fantastic for that too. So really what you need to think about today is when you're doing some activities, think about that Numicon approach. Think about what questions am I going to ask my child? How can I encourage them to talk in full sentences? How does doing an activity help them talk about the maths and see the structures and the patterns? So that's the Numicon approach. So this session is aimed at slightly older children. And I still think it's important to just give a little bit of background about Numicon. So what I would like you to do is to get a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 Numicon and organise them into a staircase. And if you were here last week, you've got an idea how to do that. So I'm just going to give you a moment to do that. And I will do the same. Apologies. There we go. Right. So when we're organising our Numicon staircase, it will look a bit like this. And you might be thinking, well, my child can already count. My child doesn't need to sort of think about one more, one less. but actually there's a really important purpose for understanding the relationships, etc. So when you're setting out your Numicon staircase, you can see that I've organised my 2 in a certain way, and I would like you to just adjust yours if it isn't exactly the same. So this is what we call a Numicon 1 to 10 staircase. And excuse me, why it's a staircase is quite self-explanatory. So as you can see, we go along 4 and we go up 1. We go along 4 and we go up 1. So some of the things to know about Numicon which will help you when you're doing the harder maths with the children. So they've all got a relationship. So the 2 shape has got a relationship to the 3, which has got a relationship to the 1. So we can see that the 2 is 1 fewer than the 3. And if we add 1 to that 2, it makes that 3. We can see that the 2 is 1 more than the 1. And if we put 2 of those things we call 1 in, it would make 2. Also, there is a colour relationship, so to speak. So every single shape has got a different colour. That's important and that's distinctive. But also, if I was to push forward the even numbers, you can see that the even numbers are all sort of blues and greens, watercolours, and the odd shapes are all hot, fiery colours. There's also a scale relationship. So the 2 is double the 1, the 3 is 3 times the 1, the 4 is 4 times the 1. And that's not just in size, because you can see that quite easily in size, but also in mass. And what's great about that, it means, is that if you were to take a 2 Numicon and you were to put it into a balance, actually put two Numicons into a balance, and then put a 4 Numicon into a balance on the other side, they would actually balance because they are equal. So there's a scale relationship, a colour relationship, a staircase relationship, and all of these are quite important to know. It's also worth knowing about the holes because they're quite obvious, but they're also useful for counting, and that is worth knowing. Now, because we're thinking about Key Stage 2, which is children age 7 and above, we're going to start to be thinking about decimal numbers, we're going to start to be thinking about fractions. So we then at this stage start to use this 1 to 10 scale slightly differently. And children are very adaptable and we talk to them about it, but we change the scale. So what we can start to do is think about what used to be the 1 as a 0.1, what used to be the 2 as a 0.2, etc. And with that in mind, we can also relabel them as fractional values. So the 1 could become 1/10, and you can see how that would work. Now, the reason it's tenths is simply because our 10 Numicon is actually our 1 whole. So these actually, that is 1/10 of that 10. So today, when we're doing a little bit of work on fractions, and squeeze a little bit in if I can, it's worth thinking about using the scale in a different way. So if you were doing some adding decimal questions with your child, don't be scared to get the Numicon out, because if you were doing 0.2 and 0.3, they could very much use that Numicon to help them. Okay, right. So what we're going to do this session is we're going to focus on multiplication, and then I'm going to do a bit of division, and then I'm going to do a little bit of fraction work if I can fit it all in. So last time I did my live stream, I sort of concentrated on recognizing and identifying numbers, and addition and subtraction. And obviously you do, children in Key Stage 1 do multiplication and division. It was just a case of not putting too much in one session. So a lot of what I'm going to do now will certainly cross over into Key Stage 1. So I just want to think about a times table. So just before I start showing you some activities, I would just like to talk about what I've chosen to do. So when parents want help with times tables, sometimes they want quick fire question ideas, or sort of apps on iPads, or ways that they can encourage their child to answer questions quickly, maybe textbooks they could buy or something like that. And we suggest all those things because they're one important part of the jigsaw. But actually what I've chosen to show you today is more about how we would teach the times tables through Numicon. because not all children can remember them. And by the time in England, by the time children get to year 4, they have to know and recall all their times tables right up to 12. And quite a few children struggle with that. So what we're going to concentrate on today is the type of activities you can do at home that are going to encourage them to say the maths facts loads of times, to be able to see the addition structure of multiplication, and just to put in a bank of ideas. So they will supplement anything else you're doing. And that's kind of the idea of what I want to do. So the first thing I would like you to think about is, how would you show 3 times 3 with Numicon? So what we're looking for, just going to move these shapes down, is how would you use Numicon to represent the question 3 times 3? So I'm expecting that you've got something like that. So what we can see there is what actually happens when we ask the question 3 times 3. We are actually getting 1 3, adding 3 more and adding 3 more again. So when we start talking about the 3 times table, now I've chosen the 3 times table for space purposes. Okay, so you might want to do this with the 7 times table or the 9 times table. But I'm doing it with the 3s just because I can't fit all the size of the shapes in. So when we're thinking about the 3 times table, we might say to the child, 1 3. We might write the maths calculation that goes along that. 1 times 3 equals 3. And then we show 2 3s. Now some children will be able to put that 3 in their head and count on in ones to work out that 2 3s are 6. Some children will do that. And the reason they do that is because then they can do that. And they can check whether 2 3s are actually 6. And again, I might write the maths calculation down. We might leave it like that. We might just add another 3 on. And I would say to them, how many 3s have we got here? And they say 3 3s. What is 3 3s? How many is 3 3s? So hopefully they might remember that 3 3s are 6 and just count on the 3. But if not, they might count individually. Now, remember, what I find is some children might not recognise that 9 so easily if it's horizontal. So you could rotate it so that they can check that their 3 3s are 9. That's a very simple idea, but all the time whilst you're doing this, you're talking to the children, your child, about what they know. So what we're gauging is, are they using, you're doing a little bit of assessment really, like we do in school. Are they counting on each time? Are they holding the number from the previous amount in their head? Are they able to predict? Because what I might say to them next is, well, 4 3s are coming next. How many do you think that is? Now, as a support for that, you could use one of these Numicon tens number lines. So you can buy these online, or actually I suppose you can make your own, because you could do some printing with paint. And sometimes these are really useful to help with those times tables. So again, I'm using 3 as an example. So I know that 1 3 is 3. I know that 2 3s are 6, etc. Now you can see why this is useful at this point, because we've got a marked 10. And for those children who don't know that 3 3s are 9, they might use this to help them. They might notice that that is 10 and spot it is 1 fewer than 10. So the answer must be 9. So it gives them a little bit of structure. It helps them count if they need to. And it's just something quite nice we use in school to ensure that they've got a bit of a scaffold if they need it. So whilst we're talking about 3s, another fun activity, doesn't have to be done with 3s, of course, is a treasure hunt with Numicon shapes. So when you're working on times tables, my recommendation is to pick one and stick with it. So in school, what we tend to do is we'll choose a times table and we'll concentrate on that for a week, sometimes even 2 weeks. And our starters and our lessons will begin with them. We might do a couple of end of lesson questions. Our homework might be based on them, but we focus on one thing at a time. So what that helps is children remember more. So I'm going to stay with the vibe of the 3s for that reason, but you could do it for any times tables. If you hide some Numicon shapes, let's say 3 times table, hide loads of 3s in the room. And the idea with this game is they have to find the 3s, rush and bring them back to you, and then we start talking about them. So, oh, you found one. You've got one of those things we call 3. Look, 1 3 is 3. Go and find another one. So off they go. So I'm asking very similar types of questions as I did last time, just scaffolding it. How many 3s have we got? we've got 2 3s. What are 2 3s? 2 3s equal 6, and we can do our checking like we did before. Okay, you know what I'm going to say now? Go and grab another one. Right, how many 3s have you got now? Etc. Now at this point, I might turn around and say, right, you know I'm going to look for the next, ask you to get the next 3. What do you think the answer is? What do you think the answer is going to be for 1, 2, 3, 4 lots of 3? Can you visualize it? Can you picture it in your head? And some children might start to count there. Some children might just know. So all we're doing here is, alongside all the singing and the chanting of the times tables and maybe listening to songs, we're just going back a bit and we're peeling it back, and we are looking at the structure and making sure our child understands what multiplication is. And you can do this for any times table. It's really, really good fun. So another fun activity, which I've done lots in school, is building a tower. Now here's one I made earlier by Blue Peter. This is a tower of 2s, and again I chose to do 2s just simply so they'd fit in space. But I think this is particularly useful when for something like the 6s or the 7 times table. Now what you do here is you need pegs. So I showed you these last week. These are Numicon pegs, and they actually fit inside the Numicon shape, so they stay together. And the idea with this activity is that they build a tower of the times table that they're working on. So if they're working on the 2 times table, they'll be building a structure. Now I had to put one at the bottom to make it stand up, but Numicon do a 100 board, a peg board. It's got 100 sort of divots on it, and they stick on that. But when they're building their tower, perhaps you could build a tower of a different value. They might want to put pegs in each of the holes to aid them with counting, or they might just use pegs as scaffolds. But once they've built the tower, you can start to ask them some maths questions. So this would be here, this would be like a floor in a car park or something. You could even say 1 2 is 2, and this would be 2 2s are 4, this would be 3 2s are 6. And they can start building the tower, and you could be pointing to 11 saying, how many 2s is this? What is that all together? You could even think about doing some division tables. So you could think about how many you've got all together and how many it's divided by. But yeah, just a fun game. They like the hands-on practical. So what's interesting as an adult to watch this is if you're doing the 7 times table, for example, are they needing to put 7 pegs in, and are they using those pegs to count? So the Numicon approach is all about talking, but also you get a chance to observe, and it tells you a lot about where they are in their maths thinking. Right, so towers. Now we're going to think about a little bit of pattern sniffing with the times tables. So again, the point of this Numicon approach is to get them to have some maths common sense, and to get them to, quite often, what I'm looking for is, can they spot a mistake? So some children find it incredibly difficult, and adults, to remember the times tables by rote. And there's arguments that it works because people say, well, I can remember my times tables from school, and some people can, but it doesn't work for everyone. So these types of ideas about pattern sniffing are helping children sort of build up a maths voice and a maths opinion. So let me show you what I mean. We were looking at the 2 times table. So I've got 1 2, 2, there we go, 3 2s are 6. And then I could even go so far as to put my 4 2s are 8 in as well. Now, what we could be talking about and encouraging children to do is to start looking at what they see and what they notice. So, oh dear, that's a bit wonky. Sorry about that. There we go. Okay, so what we're noticing is when we make the 2 times table, we're noticing something about the answers. So these are all multiples of 2. And what we're noticing about the answers is they're all even. And we know that because that's a 4, and that's a 6, and that's an 8. And from their work in early years, etc., about odd and even numbers, they remember that an odd number has a sticky out bit. So one of the first generalized rules they can start to understand is that in the 2 times table, for example, all the answers are even. So if they hear a peer in the class saying, and they're asked the question 7 times 2, and they hear someone say 15, immediately they should think that can't be right. So building on that, we might then think about the 4 times table. So think about making them. Now, again, I'm limited on space, but what I would be doing is putting as many down, or getting them to put as many down as they can. And when we start doing that, we also, again, start to notice that that rule is true for the 4s. And what that starts, or what that can generate, and you could do this with your child, is, oh, I wonder what other times tables that's true for. And they can start investigating through Numicon. So not only are they practicing their facts, their times table and division table facts, but they're also investigating and noticing what's common and what's always true. So what they can then start to notice is patterns between the times tables. So for example, every second number in the 2 times table is in the 4 times table, things like that. But just start getting some 3s out for me. Get some 3s out and see what you notice about the 3 times table. What kind of generalized rule could we come up with? I'm going to move my 2s out the way. Don't need those. Now we start looking at the 3 times table. So we've got 1 3 is 3, 2 3s are 6. And then we have our 3 3s are 9. We start to notice a very different pattern. So again, through investigating, we can find out, for example, that the pattern in the 3 times table goes odd, even, odd, even. Now that's helpful to us because we can also start thinking about which numbers create the even number answers. And we start to realize that every even multiple creates an even answer. So if there's 2 lots of 3, it's going to give an even number. If there's 4 lots of 3, it's an even number. If there's 6 lots of 3, there's an even number. So it's all about talking. What do you notice? What do you find out? About developing a real feel for multiplication and to understand that there are patterns and rules in mathematics that are really helpful. And it's not just about answering loads of multiplication questions really quickly in a row. So I wanted to think about that. What I would like you to think about now is, how would you show the 12 times table? Have a little go at doing that one. It's a personal favourite. How would you show 12 times table? So this is another fantastic example of Numicon showing structures and making the maths easier. So let's just do the first one. It's a really funny thing because in primary school, certainly in England and Wales, etc., children think that the 12 times table is like really hard and it's only the clever mathematicians that know it. And one day they can learn what 12 times 12 is. They think they're quite fascinated by 12 times 12. In fact, I always get children coming up to me in the corridor in schools telling me the answer to 12 times 12. But they have this idea that it's hard. And that can be a blocker in all sorts of areas of maths, and you might have experienced that yourself with maths. You know, when something seems a bit tricky, you can be put off it. And the 12 times table isn't tricky at all. So what the Numicon does, the Numicon shapes do, and the approach of Numicon through talking and doing and looking at structures, is it shows children what's actually happening. So when we're looking at the 12 times table, we can see that it's made up of 10s and 2s. And the 12 times table can be calculated by adding 10 and adding 2 more. And if you say to your child, here's 1 12, show me 2 12s, well, they'll just mimic very quickly. You can see I put it on top of it just to make it easier to see that it's made up of 12 and 2s. And ask them what 12 2s are and watch what they do, because again, we want to try and find out what's going on in their head. So hopefully they won't count in 2s. Some children, because they might start here, might start going 2 4 6 8. So look out for that and guide them. You know, guide them with the fact that you know that is 10 already. But actually, how do they actually get the answer 24? So some children might have taken 12 and added 10 and added 2. Some children might have doubled 10, doubled 2 and added it together. So then my next question would be, how much is 3 12s? So what tends to happen at this point, and it really does happen at this point, is before you have a chance to ask what 4 12s are, they're telling you the answer. So there's a real power in the Numicon shapes here. So before, what I tend to do is they already know that that's 36. They quickly added 10 in their head to get 46. And then they counted on 2 to get 48. And once they've started the pattern, they are flying. And what I found is children really enjoy seeing this structure, because when they are asked to recite it in class, or they're asked to do some mental maths around it or some quick calculations, they've now got a strategy. And their strategy isn't just based on memory. And it's quite intimidating for a lot of children having to remember the times tables. So what this does is it gives them a memory, it gives them a hook, it gives them something to come back to. Right, I hope you are being interactive and having a go. Can you let me know what you think so far in the comments? That would be great, and Harry will endeavour to answer any queries you've got, no doubt. What I want to do now is just show you a little bit of multiplication with Numicon when the maths gets harder. Now, invariably, when the numbers get really big, Numicon doesn't have such a useful purpose. It's like anything. If I'm starting to do 2-digit multiplication, so 32 times 48, using Numicon isn't going to be useful because I'd need too many pieces, and then the structure would be hidden because I just have Numicon shapes everywhere. So, you know, if your child's working confidently, multiplying a 2-digit by 2-digit, you wouldn't really supplement it with Numicon, but you might use it to ask them some questions to make sure they understand the structure, and to ask them questions to maybe determine if they can spot a mistake. But let's think about a question like 17 times 3. So at the early stages of multiplying, this is exceeding 12 times 3, which we would expect children to know because they know their 3 times table. So in school, we would do a partitioning method, which is where we partition the 10s and the 1s. But I'm going to show you a grid method, which also uses partitioning. So it's called the grid method because it looks like a grid. And you might have seen it at home. You might have seen it sent home from school. So we partition this 17 into a 10 and a 7, and then we're going to multiply it by 3. So that's how we set it out. Now, what's great about Numicon is it will help with this calculation. So what we're going to do is we're going to work out what goes in there, and then we're going to add it to what goes in there, and that gives us our final answer. But we can demonstrate this with Numicon. Now, I haven't got much space, so I'm going to pile my Numicon on top of each other. But when you're doing it with your child, it would be better if they could see all the pieces. So 3 lots of 10. I put that one there. Okay, and 3 lots of 7. So I've partitioned 17 into 10 and 7. I'm going to multiply them both by 3, and I'm going to add them together. So at this point, it might be that you possibly bring your number line out, or if children are multiplying these types of numbers, we would expect them to be able to use a column addition. We'd expect them to be at the stage where they could add decent sized numbers. So I would be looking for your child to hopefully be able to tell you quite quickly that 3 10s are 30. It might be that you take them out and replace it with a value. And they might know that 3 7s are 21, or if they need to count them, then we're looking for them to put the first 7 in their head and count on. They might know double 7. I'd always say to the children, well, you know your doubles, so double 7 and add 7 more. And they can do that, they can count in the holes if they need to, and they would work out that that would total 21. And then because I've partitioned the number, I need to add them both up together. And as I said before, it might be that they go 10, 20, 30, 37, 38, 39, 40, 41, 42, 43, 44, or it might be at this stage then they put it into a column and added it that way. Okay, so what we're doing is we're just helping them visualize the maths behind 17 times 3 and seeing what it might be like to have countables. So as the maths gets harder, obviously we wouldn't represent too big a number, but have a look and see where your child's at with their multiplication. If they're moving into formal methods, see what they can do, see if they know of a grid, and if they don't use a grid, then if they have used a grid before, the Numicon might work really well. So it's got to be worth a go. Right. So what I'm going to do now is show you a couple more ideas that just supplement multiplication. In all honesty, you could do them too for division. Either would work. So actually, most of the things I've done really for multiplication can just be flipped on their head for division. We don't tend to teach them too discreetly in primary school. We might teach a little bit first, just so they've got a concrete understanding, but we're always talking about the relationships. So here are just a few more ideas about what you could do. So painting with Numicon. So last week, I'm a big fan of Numicon and paint. So Numicon's brilliant for painting because it's durable and it's washable and all those things. And just because you're age 7 and above doesn't mean you don't like painting. So what I was thinking was how you could do a similar type of idea to this, but with Numicon, but for multiplication. So I was thinking that they could have to paint a picture which only uses numbers in the 5 times table, or they might have to make a picture which has 35 for the body, and they need to be able to show the division. So they need to be able to show what 35 divided by 5 is on their picture. So drawing a picture, painting a picture, anything you like, but representing the same value lots of times is really helpful. So, just again, something that you can do easily at home. You don't have to do it with paint. You could do it with plasticine. What I find sometimes is I don't quite have enough Numicon shapes. So if I'm doing the 7 times table, I need loads of 7s. So I often opt for plasticine because then I can print them in and then I've got endless amounts of 7s and the children can help me make those too. So think about using plasticine if you haven't got enough of each shape. Just to refer you back to Numicon City, if you've watched the last live stream, it's a really popular activity. It went down quite well on the stream, and it's the idea where you kind of create a landscape or a skyscrape picture with Numicon shapes. So you could be doing, give your child a Numicon City, and they could, certain buildings all had to be 5s, and you could count how many 5s you got in there for the 5 times table, all things like that. So just picking up fun ideas and just practicing those times tables, because that's all we're trying to do. And you can draw pictures the same way. It doesn't have to be with paint. All I'm trying to do is do the same thing lots of times. And that's what we try and do in school. Right, the balances. So I am a big fan of the balances. These are the best kind because they've got transparent boxes. So if you have got any at home, or you're going to invest in any, do try and get the ones with the transparent boxes because they really do work well. So this is great for multiplication and division because it's the same thing lots of times. So for example, you could get, if you're looking at the 8 times table, get a load of Numicon 8s. If you were to put 5 Numicon 8s on one side and 40 on the other side of the balance, they would balance because they are equal. So they can do lots of investigating of answers through that. So if you gave them a couple of division questions to do or multiplication questions to do, you might say, check 3 of them with a balance, see if you've got the right answer. Another thing that you could do is you could investigate answers that are in more than 1 times table. So think about the number 24. It's got loads of factors. So it's in the 24 times table, the 12 times table, the 3s, the 8s, the 6s, the 4s. You do a bit of investigating about that. So if you had 4 6s on one side and 8 3s on the other side, they would in fact balance. So you can play around with the balance and do lots of different things. You could put wrong answers in the balance. So can they work out why it's not balancing? That's a good one. Or even get them to put a wrong answer in. So can they actually work out what needs to go in the balance if you want them to not balance? So yeah, balance ideas with multiplication and division, it lends itself absolutely beautifully. So have a go at that. And I'll put the last 2 up together. So I've put a Numicon post box, but it really doesn't have to be a post box. It could actually be a feelie bag. So I talked about feelie bags last week. So feelie bags are really great as long as they're not transparent. The opposite to what you want from the balance. But I'll use the Numicon post box as an example. And somebody talked about having a Numicon, a real box last time where you had 2 hands to put inside to feel things in, which I have definitely. It's definitely one I'm going to use. But if you think about a post box, there's loads of things you could do. So even if you didn't want to use the post box idea, you could just say show me or give me. So I might say to the child, give me the answer to 4 times 5. Give me the answer to 30 divided by 10. Give me a multiple of 3. And all this time, they're either posting it through the post box or passing it to me, or they could have numbers in a Numicon shapes in a feelie bag, and they could be finding them and passing them to me. So give me a number that is not in the 7 times table. Give me a number that's greater than 50 that is in the 8 times table. Just keep going on. Give me a number that when you divide it by 5, you'll get a remainder of 1. So that's a really tricky idea. But I'm not expecting, and you shouldn't expect your child to be able to instantly give you these things. But if they've got the Numicon shapes, they can explore it. So they might use the number line. They might just get the shapes and count them on. They might use some pegs to help them. But the point with all this is you can ask them deeper questions, and it's not just about answering loads of fast questions, like, in a list or something like that. My last point was about number lines. I wanted to mention that because multiplication is often seen on a number line. So that's the 6 times table. And Numicon is one representation. And what you'll find in your child's school is that they don't just use one. So Numicon is one of many things your teacher uses to help your child learn their times tables. So number lines are really popular, and all I was going to say is if you are aware of any strategies or any things that your teachers already use with your child, use them and bring Numicon on top of it. So I would be looking at that number line, and I would also get 6 Numicon 6s out to help me with that. Right, okay, so that's a really quick, fast tour round multiplication. The whole point of it, as I've said before, is about talking and communicating and doing. And now I'm going to talk a little bit about division. And I get a bit excited about this because I think that of all the things that I've done with Numicon, probably division is my favourite. And you'll see why in a moment, because it just makes so much sense. But the first thing I want to say before I start showing you division with Numicon is that early experiences of division is usually through sharing. So if you think about your child's sort of early experiences of having to share some things, what normally happens is they have, let's say, 6 things, and they are asked to share it between, say, 3 people. And we normally give them things, we normally put it into context, it might be about apples or something like that, and they will be asked to share it. And what they tend to do if they're sharing it between 3 people is 1 here, 1 here, 1 here. That makes sense, doesn't it? So that's probably what you do at home when you are talking about sharing. But as the maths gets harder, sharing becomes less efficient. And as your child moves into Key Stage 2, so as they move in, as they're 7 and above, they start using bigger numbers, and therefore sharing is quite a lengthy process. They actually start using the method of grouping, which is another approach to division. So Numicon lends beautifully to a grouping method because it's fixed pieces. So if we're dividing by 4, we're finding 4s, 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 and Numicon lends itself to that. So what I would like you to do is I would like you to look at your Numicon pieces and think about how would you show 20 divided by 4 using Numicon. So how would you show 20 divided by 4 using Numicon? So have a little go. Now, I'm putting it in a linear way, and I'm going to show you why in a moment. You may have done it that way. And there's nothing wrong with that, but this other way is foolproof. So I'm going to ask you to turn your line, your strip of Numicon that way if you haven't already done so. So if I'm doing the calculation 20 divided by 4, and again, I've chosen smaller numbers just so I can model easily in the small amount of space I've got, but you would find this useful for the harder tables too. 20 divided by 4, I'm investigating how many 4s are in 20. So I get my Numicon 4 and I put them over the top. Now, why this is great is because it looks at the 4, the divisor, as the important part in the division question. So children catch up on that really quickly. Now, some children like to put it underneath so they can see easily, but we can see very clearly that 20 divided into 4s equals 5. So just have another go, just do another one, just do say 27 divided by 9. Have a little go at doing 27 divided by 9. And the reason this works so nicely is because it's so visual. So I was working with a little lad who was finding division really tricky, and he was about 7 or 8. And I did one example, and he sort of perked up. And he was like, okay, hang on a minute. I did 2 examples in total. I didn't do any more than 2. And by the time I went to do the 3rd, he was snatching the Numicon off me, wanting to take charge. So it took 2 examples. And I've been teaching a long time, and I'm very experienced, but I don't think anything could have done it better than that. I don't think any other things that I've got in my repertoire could have done better. So you've just been thinking about 29 divided by 7, did I say? So you would have got 29 and the Numicon 7s, and you would have investigated how many 7s are in 29. And you would have found out there's 3. So really quite straightforward. That goes for all sorts of numbers. Same maths idea. If you want to, you can use the number line. If you're using bigger numbers, remember that this number line does also go up right up to 100. So it gives you some opportunity to do some more Numicon with that. This is the bit I particularly get excited about. So what we're going to try now is, and again, I'm using smaller numbers just for ease of demonstration. What I would like you to do now is I would like you to have a go at doing 14 divided by 7. So 14 divided by 7. So already, what you're noticing is that fits perfectly. Now I wanted to show you the dividing by 7 or a dividing by 9 because some children find it really difficult to put and match them together. So there may be some time where they need to just do a little bit of rotation and practice with themselves and make it fit. But do watch out for that, and that's why I wanted to show you, because sometimes they get a different answer because they go, oh no, it didn't fit. So do make sure that you give them a little bit of time to work that out. Right, so what we're going to do is a much simpler one than that. I'm going to ask you to do 13 divided by 4. So we're going to make 13. We're going to divide it by 4. And what you'll notice straight away is when I'm dividing by 4, I have a remainder, and that is the beauty of Numicon. It is sitting there ready for you to see. And what a lot of children might say to me is if I ask them 13 divided by 4, some children will say to me, you can't do it. And I'm like, you definitely can. But because 13 isn't a number in the 4 times table, they think that you can't divide it by 4. So what Numicon does is bring that alive. So that was 13 divided by 4. And when we look how many 4s we've done, we can see there are 3 4s and we have 1 remaining. So we can write it like that. Now, the one I would like you to do the next is 14 divided by 4. So I've just added 1 to the 3 to make 4. So if you give this to your child, they might need to take it off, and they might want to take that off and put a 4 shape in. But what I'm looking for them to say is that it's still going to be 3, but there are 2 remaining. Now I'm on a pattern sniff here and I'm thinking, oh right, what else do they know? So the maths is quite easy, but I'm really trying to emphasize what a remainder is. It's a bit left over. So I might say to them, what do you think I'm going to ask you next? And many children will, I know what you're going to ask me. You're going to ask me 15 divided by 4. So I might say to them, okay, well, if you know what I'm going to ask you, what do you think the answer is going to be? And I would see if they could try and visualize what would happen if they added 1 more to this 14 to make the 15. And hopefully they will start to deduce that if they're adding 1 more here, they're going to have 1 more in the remainder. So, you know, this pattern sniffing, rather than just going 13 divided by 4, 28 divided by 9, 31 divided by 2, a whole list of different calculations, we can start to pattern sniff. At this point, I might say to the child, you know what I'm going to say next? Give me the answer. Give me the question that goes with 3 remainder 4. Now, it's quite a big jump. I'm jumping through the ideas quite quickly, just for demonstration purposes. And you might need to do lots more of this first. But what I'm obviously looking for then is, are the children going to say 16 to me? Are they going to follow that pattern? Are they going to say if we add 1 more here, if I just, more 1s left. We add 2 more 1s. If I make 16, are they going to say that I've got 3 remainder 4? Well, it's a great opportunity to show that, of course, you haven't got 3 remainder 4. It is not equal to 3 remainder 4. It is equal to 4. And we can have conversations about remainders then. So what we're trying to do is get a generalized rule from the children that when we're dividing by 4, the maximum remainder that we can have is remainder 3. So that when they start doing short division and harder calculations, they start noticing if they've got a remainder that's greater than the divisor, the number they've been dividing by. So that pattern seeking is really important and quite good fun. So again, we're just going to keep building on that, and we might do lots of those questions. I am going through scaling up quite quickly, But I might say to them, okay, well, if we know that 16 divided by 4 is 4, what is going to be the next number that you can give me that's going to give me a whole number answer? Or give me another number when divided by 4 that would give me a whole number answer. And they might be able to be quite systematic and just go straight up to 20 divided by 4. I might even say to them, okay, well, look at the pattern. What about the question that's going to give me an answer of, oh, sorry, everybody, 5 remainder 1. So if 20 divided by 4 is 5, what must be divided by 4 to give me 5 remainder 1? So again, they can make it, discover, find out, and finally come to that conclusion. So you can see there is so much that you can do just from a simple build of Numicon shapes. So I really, really think that it's really worth a try. I would really, really is my favourite. And I really do think that one of the best things of all of it is definitely the remainders. Right. Okay, so to finish off, we are just going to have a little look at some fraction work. And fractions are really big, and quite a few years ago in England in 2014, the expectations got a lot higher in primary school for fractions. And I certainly know that a lot of the work that I do in primary now is actually stuff I did in secondary. So it can be a little bit tricky for children. And what I would like to do today is just talk a little bit about some recognising and identifying, and then just show you a couple of ideas, really simple ideas that you can use if your child is doing any calculating at home. So what I would like you to do is I would like you to represent a quarter for me. So show me using Numicon. That was going to happen at some point. Show me using Numicon what you think a quarter would look like. And I'm going to write a quarter on here. Now, as I've said before, Numicon is just one representation. We use loads. So in school, we might write 1/4. We might write 1 out of 4, 1 over 4, 1/4. We talk about it in lots of different ways. We might draw diagrams like that and label that a quarter, because 1 out of the 4 balls is white. We might draw bar models, which show 4 equal parts for quarter. And then we might also use Numicon. So last week we talked about representing the number 5. It's the same idea actually for Numicon. And most children will represent Numicon 1/4 like that. Now I'm going to draw the divide by line in, but you'll find that your child might like to put their pen down. That's what I find. They seem to like to use the pencil. This is the divide by line or the vinculum, and they like to do that. So that there is what 1/4 might look like. And you might just spend time with your child getting them to draw a diagram and represent a quarter in lots of different ways. And it could be doing more of what I've put on here. So you might show a clock or get them to draw a clock and think about quarter past. That would be quarter past 2. Oh dear. 2:15. Something like that. So thinking about a quarter in lots of different ways. You might draw a jug and show it quarter full. But using Numicon as well absolutely helps. Now we will represent it, and we use that representation when we do things like this in school, but we also start to use it when we do a bit of calculating. So one of the things we do for calculating is to help children have a conceptual understanding, a deeper understanding of how to calculate fractions. But before we do that, I want to talk about an equivalent fraction. So you might have seen homework being sent by the school where your child has had to list lots of equivalent fractions. Now, equivalent fractions are fractions which are equal in value. They have the same value, but they might well have a different appearance. So we use equivalent fractions in mathematics when we try to problem solve and things like that, because we try and make the maths easier for ourselves. So that's where it becomes really handy. So let's just think about an equivalent fraction for 2/3. So you could represent 2/3, and I want you to have a go now at thinking about how would you represent that as an equivalent fraction, and what does that actually mean? So to make a fraction equivalent, to ensure it's equivalent, we need to make sure we do the same thing to both the numerator, which in this case is 2, and the denominator, which is 3 in this case. So we can multiply them both by the same number, but whatever we do, we need to do it to both of them. So if I model that out, sometimes we write a ×2 like that in school to show them what we're doing. We can model that out with Numicon. So I have to do it on this side because of the lack of space. But if I'm multiplying the numerator by 2 and the denominator by 2, I can see what my new equivalent fraction is. Same value, different appearance. So I've got 2/3 and I've also got 4/6. And I can continue with that idea. So I could actually then consider multiplying it by 3 and so on. So my numerator then would be 3 and my denominator would be 9. But what this does is just make sense to the children what the maths that they're doing is. So when they're trying to find equivalent fractions, they have to remember to do it both to the numerator and the denominator they're multiplying. So I think this idea works really well to help them remember it. And also thinking about finding an equivalent fraction by dividing down. So it's the same sort of idea. So I could divide both of these by the same value to get my equivalent fraction. So as long as I do the same to the numerator and the denominator, then I know I have done my job right. So equivalent fractions through Numicon works really well. They're going to come in handy in a moment when I do my demonstration about calculating. But what I want you to think about now is, if I gave you the question 2/10 add 3/10 and asked you to show it with Numicon, what would you do? Have a little go. 2/10 add 3/10. So I'm hoping that you will come up with something like this. Draw our divide by line in, and we can put our add sign in. So what's the answer? That's the first part. So I'll tell you now that 2/10 plus 3/10 is actually 5/10. And when we start teaching adding fractions, loads of children get this wrong because they see the add sign and they do it right for the numerator, the top number. They add the 2 and the 3 together to give them the 5. But because there's an add sign, they add the denominators too. And that gives us an answer of 5/20, which is incorrect. Now, what I love about Numicon is it helps me teach the children better, basically. It helps me model this out so it sticks in their mind. So let me show you what I mean. I was thinking about 2/10 plus 3/10. I could use my Numicon 10 piece. So that's 10/10. This is equal to 1 whole. It's like if you got 10 out of 10 in a maths test, you'd have 100%. It would be the whole thing would be correct. So let's think about 10/10. Now, if I'm going to add, let's put it into context. Let's pretend this is a cake with 10 pieces. So the 2/10 I'm going to put on there, I'm going to represent there, and that's the bit that I ate. I ate 2 pieces of the 10-piece cake. And then Harry came along, sorry Harry, and she ate 3/10 of the cake. Now, if we want to know what 2/10 plus 3/10 are, we're going to add the shapes here. So we're going to go 1, 2, 3, 4, 5. We can see that there are 5/10. This cake hasn't doubled. There aren't suddenly 20 pieces like there would have been if we added the denominators. So by putting the 1/10, the tenths out for the children and getting them to lay the pieces on that they're adding together to the 1 whole, it works really, really well. And it really helps to remind them not to add the denominators. So I absolutely love that. So let's just think now about how would you do, let's say we had 6/8 take away 2/8 with Numicon. How could you do that? If you came to the session last week and we talked about subtraction, one of the things we talked about is how Numicon does work well with subtraction, but you just need to adapt it a little bit and play around with it a tiny bit so that it makes sense to the child when you're modelling. And it's the same idea here. So if I was going to do 6/8, so I've got my 8, 6/8, I've represented it, and then I've represented my 2/8. That's a mistake I've made straight away. Because what I don't want to do is represent the 2/8 as well, because if the child takes 2/8 away, then they say, well, I've got 6/8 left. So I've really got to be careful with that to not model the second number. And when we talked about subtraction last week and we started using the pegs, that stopped us modeling the number. So what I recommend that you possibly do for this one, put your divide by line in, is fill it with pegs or marbles or Cheerios or something. So what we could do, you could do it with plasticine, you could do it with paper, and just show those 6/8 on there. What I then actually do, just to keep it similar to the model of the same model of that we did for addition, I might put them in there so I can just show that I'm not taking the eighths away, because the answer to this is 4/8. We don't take the denominators away, so just to emphasize that, I might put it in there. So we've got 6/8, we're taking 2/8 away. How many eighths have we got? And we can count, we've got 1, 2, 3, 4 eighths. So that works really well. So think about how you could use Numicon for subtraction with fractions. And the last sort of Numicon model I want to do for you today is just thinking about adding fractions with different denominators. So if we had a question like 1/5 add 2/10. So a lot of children, by the time we get to unlike denominators, we've hopefully secured it in their brains that they don't add the denominators, so they're only adding the numerators. But what we do talk about is to be able to add them, they need to have the same denominators. And until they do so, we can't do the maths. So we talk about them changing them to a common denominator. Now, this is where your use of equivalent fractions comes in, because if we represent 1/5, I go doing this at home and have a think about what you think we might do to make these equivalent. So we've got 1/5 and 2/10. So now we need to make them the same denominator or an equal denominator. So we could use this fifth, and we're thinking, how many times does 5 go into 10? Or how many times, or how do we make 5 into 10? Well, we double it, we times it by 2. We can see there that if we times 5 by 2, we actually make 10. So with that in mind, if we times that by 2, we need to times our numerator by 2. So we do exactly the same. So we'd multiply our 1 by there. So what we can see now is that we've got actually 2/10 add 2/10. And to be consistent, I might get rid of that. Keep the numerators there. Put my 10 there. Put my 2/10 there. Put my other 2/10 there. And say, how many tenths have we got? So 2/10 plus 2/10 equals 4/10. And obviously, I could do exactly the same if I was using decimals too. Right, just to finish off, I just want to quickly talk you through some harder questions, and I just want to show you a fraction robot that the robot seemed to go down particularly well last week, so I thought it would be worth bringing up again. But before I do so, I would just like to show you some problem-solving questions that you could do at home. And I did it this way last week, so we did lots of hands-on activity, and then we thought about making it harder. So when we're thinking about multiplication division, so these problems are for multiplication division, again, we don't need to go really hard with the numbers. So to ensure our children have a good understanding, we want to talk to them and get them to reason. And parents often ask, don't they, how can I make it harder? Well, these are some of the ways you could make it harder. Ask them questions like this. So I'm using a feelie bag as an example for these ones. So I am going to put 3 shapes in my feelie bag, and they are going to total 21. And the idea is that your child has to work out what is the shape, or what are the shapes. So it's the same shape 3 times, and it equals 21. So if they know their 7 times table quite well, and you've done lots of work on the 7s, they might be able to say that quite quickly. But if not, they could get the Numicon 7s out, they could start totaling, they could make 21 and investigate by putting the same number lots of times on top of it, anything like that. So this one, I have a value of 12 in my feelie bag, and all the shapes are the same. So we are thinking about multiplication here, or division. What shapes could they be? So this is a more open-ended question, because 12's got quite a few factors, so I know that's going to work nicely. So I could have 12 ones in my Numicon bag. I could have 4 3s, I could have 3 4s, I could have 2 6s, I could have 6 2s, etc. So the idea with this one is getting them to work out what they could be, but also then from that working out what they can't be. And it's interesting when you talk with your child to work out which one they can do more quickly. So I'd be looking for a full answer sentence. So if they said to me, oh, well, they can't be 5s in the Numicon bag, I'd say why? And I'd hope they would say, well, they can't be 5s because 12 isn't in the 5 times table. So it's that kind of thing. So Harry and I have equal values in our feelie bags. We've got one each. So you can do this with your child. You could have one feelie bag and or prepare to if you want to do it that way. In this case, Harry's got 2 of the same shape and I've got 4 of the same shape, but they're equal. And the job is there that the child has to work out what are all the different possibilities that we could have in our bag. So again, they don't have to do it all through a visual. You could get some Numicon scales out and start investigating 2 of one shape on one side and 4 of another shape on the other side, and when they do balance. But that will keep them quiet for quite a while. So get them investigating, getting them to write all the possibilities, getting them to predict as they're going along. So, picking them up on what they're saying and getting them to elaborate more. So my feelie bag, I have lots of the same shape, but my value is an odd number. So which times tables could it not be? So this picks up really nicely on the pattern seeking we were doing earlier, where I talked about the 2 times table and the 4 times table all having even number answers. And hopefully at this stage then, in this kind of deeper questioning, your child would either have to investigate or be able to say, well, it definitely can't be an even number you've got in your feelie bag, because you will not get an odd number answer. Right, my final thing I wanted to show you today was a fraction robot. So that seemed to go down really well last week. You all made your 25 robots. So this time, to finish off, you're allowed to make another one. But this time I'm not giving you a limit, so you can choose any value you like. And the children quite like this, to have an opportunity to go as big as they can. But what you're going to do with this one is you are going to describe your robot using fractions. So let's imagine that you made your robot, and when you added all the bits together, it equaled 32. Well, the 32 would be your denominator, your number on the bottom. And then what you do is you start to get the child to explain and describe all the different parts of the body using a fraction. So for example, if their body was made up of 8, the fraction of the robot which is body would be 8 out of 32, and you could do some simplifying around that. So you can get them to describe all different parts, and you can start making sense of that. So if they've happened to give their robot really long arms, you can talk about what fraction of the whole amount that is. But there's lots of talking that you can do. You can get them to calculate different parts, so what fraction of the body is the arms and the legs. You could make one alongside them and get them to compare it. How are ours similar? How are ours different? You do some subtraction with it. There's absolutely loads you can do. So, fraction robot, have a little go. Right, okay, so I have come to the end of the live stream. I hope you have enjoyed it, and you're going to be going away with loads of ideas and suggestions and tips for how you could use Numicon at home with children from the ages of about 7 to 11. Just to mention that I've actually set up a YouTube channel. So this video is going to be going on my YouTube channel. It's called Curious Maths. I would love it, because it's new, I would love it if you could go and subscribe to it. And if you hit the bell for notifications, you'll be informed when I've done a new video. But I think moving forward, that's what I'm going to do, is I'm going to put my videos straight onto YouTube, because they don't have much shelf life on Facebook. They get scrolled down the page quite quickly. I'd really love to know what you think. So if you could send me a message now and tell me what you thought of this session, and if there's anything else that you would like me to concentrate on. But thank you so much for coming out on a Monday evening, or not coming out, staying in on a Monday evening and tuning in, and get stuck in with the Numicon and enjoy yourselves. So wishing you well, and take care of yourselves, and take care and have a good evening. Bye-bye.